There will be instances where you will come across half reactions where the number of electrons gained and the number of electrons lost are not equal. Therefore, you cannot cross out the electrons and write the overall reaction. When you come across this situation, we must manipulate the half reactions to ensure that the number of electrons lost equals the number of electrons gained, similar to the way that we manipulated equations in Hess's law. The steps to follow are: 1. Write the half reactions, including the number of electrons. B. Balance each half reactions for the number of atoms or ions. C. Balance each half reaction for the charge. And then D. Add the half reactions together. You can see these steps at work in this example. We have to balance the following redox reaction, where we have Ag positive plus copper goes to copper 2 positive plus Ag solid. When we're writing out the half reactions, again, make sure that the elements match up. Ag positive goes to Ag solid, and Cu solid goes to Cu2 positive. Then we need to add the electrons. To do that, we look at the overall charge of the reactants and the overall charge of the products. The overall charge of the reactants in the first half reaction is 1 positive, and on the product side we have 0. Again, we always add electrons to the higher number, so we're going to add electrons to the reactant side, and we need to add 1 electron because 1 minus 1 equals 0. Then, for the second half reaction, on the reactant side, we have an overall charge of 0, and on the product side, we have an overall charge of 2 positive. We add electrons to the higher number, so that would be to the product side, and 2 minus 2 makes 0, so we need to add 2 electrons in this case. You'll notice here that the number of electrons gained does not equal the number of electrons lost, which means we need to proceed to step 2. In step 2, you have to balance for the number of atoms. In this case, we don't need to do anything. We have 1 silver and 1 silver, 1 copper and 1 copper by looking at the coefficients. Now we need to balance for the charge. We need to make sure that the number of electrons lost equals the number of electrons gained. And you think about manipulating this in the same way as Hess's law. I have 1 electron in the first one. We have 2 electrons in the second one. In order to make sure that we have the same number of each, I can take the entire first half reaction and multiply it by 2 like shown in step C. When you multiply it by 2, however, you multiply the entire half reaction by 2. So we have 2 Ag positive plus 2 electrons goes to 2 Ag solid. And when we do this, the number of electrons lost equals the number of electrons gained, and this can be cancelled out. Let's go through this example. Balance the following redox reaction. Well, the first step that we're going to have to do is we're going to have to break it apart into its 2 half reactions. Au3 positive, aqueous, goes to Au solid, and Zn solid goes to Zn2 positive, aqueous. Now we also have to add the number of electrons in the right place. In the first half reaction, the reactants have an overall charge of 3 positive, whereas the products have an overall charge of 0. We add electrons to the higher numbers, we have to add them to the reactant side, and we'll have to add 3 in this case because 3 subtract 3 makes 0. For the second half reaction, the reactants have an overall charge of 0, and the products have an overall charge of 2 positive. So I'll have to add 2 electrons to the product side to make sure both sides are equal. At this point, I cannot add the 2 half reactions together because the number of electrons lost do not equal the number of electrons gained, and we'll need to manipulate it to make it so. To do that, I have to multiply the first half reaction by 2 and the second half reaction by 3 because the lowest common denominator here would be 6. Therefore, we have 6 electrons plus 2 Au3 positive goes to 2 Au solid, and 3 Zn solid goes to 3 Zn2 positive plus 6 electrons. Now the number of electrons lost is equal to the number of electrons gained, and that can be cancelled out to write the overall 3 Zn solid plus 2 Au3 positive goes to 2 Au solid plus 3 Zn2 positive. If this was something that you struggled with any of the questions 1 or 2 on the worksheet, you can now go back to those questions and complete them.